All right. Um, Thank you so much for letting me have the opportunity to present, and thank you, Tridge, for the great presentation that you showed before. You'll get to see one of those web-based interfaces right away, actually. So me and my colleagues at Remote Aero started working with the Swedish Sea Rescue about a year ago. So they had already quite a capable platform, a drone and a launcher, but needed a way to integrate their drone data and video into one platform that would scale across their organization. So that led us to develop a few software models that we together call a ground control software stack. That's essentially tailored to provide early situational awareness in search and rescue operations. So let's see. I will start off by presenting me and my colleagues. So I'm Alexander Sandstro. I'm from Stockholm, Sweden. And I studied computer engineering with a specialization in embedded systems. I also previously worked as a boat mechanic, and I'm an avid sailor. Together with me in the company, I have Fredrik Falkman, who is co-founder and CEO. He is also head of innovation at the Swedish Sea Rescue Society. So he has a lot of experience in drones for the last maybe 8 years, both in terms of hardware as well as European regulation. Last but not least, we have Björn Bringet, who acts as a technical advisor and board member. He is an avid tinkerer, and from everything to electric bikes to drones, and also brings invaluable experience to the company, having had several leading roles within technology at Google and Volvo, for example. So to give a bit of background, the Swedish Sea Rescue was formed about 100 years ago, so in 1907, due to a severe lack of resources put into sea rescue by the Swedish government. So the seafarers in Gothenburg at the time took matters into their own hands and started raising funds to build a rescue vessel that would go out and answer distress signals. So they funded this through donations from families and the companies there, and manned these boats by volunteering themselves. The organization has grown into 75 locations throughout all Sweden. It might be hard to see, but yeah, we're in Scandinavia now, in the north of Europe, with a small map up there. So the organization is still funded purely entirely by donations, and have a fleet of more than 250 vessels spread out throughout the country. They have more than 200,000 donating members, donations big and small, and over 2,500 volunteers manning these vessels 24/7, 365 days a year. So one problem that they've had is that when someone is in distress at sea, there's usually a lot fewer witnesses than when something happens on land. So the person in distress is usually the one making the call and calling or making the distress signal. This leads to stressed and confusing calls at times, and this lack of information early on makes it really hard to coordinate these operations. So that's why around 8 years ago, the Swedish Sea Rescue started looking into the use of drones to provide early imagery in maritime accidents. So they started designing a system, and here are a few of the requirements that they had when starting out. So they would need real-time video and control of the drone in order to provide those early images. It would have to be at the scene in less than 12 minutes, which is the average time it takes for the person or the people on call to get ready and get out in the boats. It would have to stay at the scene for about 30 minutes, which is the average time that it takes for the crew in the vessel to get to the actual situation. It would preferably be able to land in water, as it wouldn't have to fly all the way back, so it could stay for as long as possible at the situation. And due to the nature of the Swedish Sea Rescue Organization, that it's funded by donations, ideally it would be on display when idle. So this would generate, for example, someone or many donations or many donators want sort of their name put on the thing that they've donated funds for. So in this way, they could generate more donations and improve sea rescue in general. So this is the system, a design of the system that they came up with. So this is a computer-generated image with a launcher / display window with the drone inside it, and that's a fixed-wing drone to meet the requirements placed here. So this is the plane that's been designed in the project. So a few years ago in 2020, they got funding from the Swedish government to start building this system. So it's a delta wing that has about 85 centimeters in wingspan, comes in at about 900 grams. It can fly for 10 minutes at its maximum velocity, so about 30 meters per second, followed by another hour at its maximum endurance velocity at about 12 meters per second. It has a 4G connection and also what we call a flight terminator, which is a redundant way to sort of cut off the power in case we would lose control of it at any point. It also has a custom-made gimbal. So this is a gimbal made to be very light and as flush as possible to the body of the airplane. It houses, well, it's a servo gimbal with 3 axes of control, and it houses a regular Raspberry Pi camera module, as you can see in the lower left design. In the project, a custom carrier board, which is also open source, has been developed, which houses a compute module, the flight controller, the GPS, as you can see on top, and a few other sensors. The launcher that's been developed looks like this, standing outside the Swedish Sea Rescue offices in Gothenburg. It can, a bit laggy the internet connection, but it can open, as you see now, as well as turn to fit into the wind, elevates and pitches in order to launch the drone. It also has a camera, which you can see the white thing in the front there. So in order to see that the coast is clear before launching it remotely. We can look at a launch. See if I click correctly. So this is a launch in slow motion. It uses the... Yeah. So this is about how far they came in the first iteration, the funding that they got in 2020. Now with a drone up flying, they started to hit certain bottlenecks in their operations. So first, the setup of both the drone and the pilot was unscalable. They needed a way to configure both the drones and the ground control stations quickly and in a way that would scale across an entire organization. Although tools like Ground Control and Mission Planner have been essential in the development of the drone, the Swedish Sea Rescue were interested in a much narrower feature set. So this made it necessary for them to sort of bring those features that they really needed to the forefront of the user interface, which I will show you in a second. They also needed to have different roles for different people acting with the system. So you would have a pilot, but you would also need someone that would just look at images and relay information to the actual rescue, to the crew members and the different resources available. And they also needed many external integrations. So for example, the AIS, which is the transponder system at sea, and ADSB, which you're familiar with probably, as well as some other integrations, which I will show in a bit. So when we started working with this, we took a classic web approach with an API in the center, which the drone would connect to. And then we would have a front end which the pilot would connect to the API through. The front end would also allow for different views based on your role. So you could, for example, be what we call a spectator in the system. So this is a person sitting in a rescue central, for example, where they receive the call and control the assets available for the operation. And so they could watch and get the real-time data from the drone and relay that to the appropriate resources. You could also have endpoints, or we also have endpoints aimed at a specific crew member that's in charge of maybe communication and relaying information to the rest of the queue on board. And the external services. So this is a view of our interface. It's a web-based interface. So I will take you through. It's a bit blurry, but so on the left here, we have the map view through which we control the drone. We have up in the top right a data and control window with the ability to set things such as altitude, speed, loiter radius. And in white, we see data such as airspeed, ground speed, altitude, battery levels, voltage, etc. So having a closer look at the current mission. So we have, we really boil it down to just use go-to points and fly in guided mode. So, and to look, we have the option either to use points of interest, which points the camera automatically towards a GPS point, for those of you who haven't used that before. We can control it manually through the Aero keys, the camera, that is. So here we see a go-to point placed at the southern island here with the route displayed, as well as a point of interest, which is shown here with the crosshair right to the left of the drone here in yellow. So to send a new command, we simply right-click in the map and we get a context menu. So either set a new go-to point, set a new point of interest, or set them both at the same location. We click and we see that the gimbal cone also turns there. So we also have this emergency panel. It's impossible to read, I think, here, but this gives the pilot quick access to some emergency commands. So, for example, if you spot a large ferry in front of you, or there's a search and rescue helicopter coming in, you can either climb or descend quickly to a specific altitude. Here is also an option to trigger the flight terminator, so immediately cut the power to the motor. So moving on to the video side of the interface. Unfortunately, we have quite strict regulations regarding if we can share aerial imagery in Sweden, so I can't show you any of our actual footage. But here, in a way, in the top right of the interface is the real-time video feed. And we have some data being shown here. To the bottom left, we have the yaw and pitch angle of the gimbal. In the top left, we see the name of the drone. In the top right, we have the time and the delay of the video feed. And in the bottom right, we have a few controls. So either to zoom in and out, or to adjust the point of interest, or manually control the camera. In the bottom here is a custom view that we've developed, which we call a scrubbing interface. So this is a way for the pilot or spectator to turn back time or to look back in the video feed. So one big drawback of using a fixed wing is that we can't stand still in the air unless we have a lot of wind. But this way we can let the users look at earlier images. So they can also, in this interface, select. So go back to an image, select that, and then do something with it, send it to a crew member on board, for example, or just mark it for themselves. So we also have a feature we call locations, which is a way for a spectator and a pilot to communicate and send locations in between them. So in this case, we have two tabs open. So to the left is our pilot, and to the right we have our spectator. So we can see that the commands from the pilot, as well as the drone data, is being forwarded to the spectator. Now the spectator, yeah, you can see placing a new point of interest. And now we switch over to the spectator view, where we punch in a new location. So it says, look here. And then the pilot gets that information straight away. It follows the instruction of the spectator, and I think the spectator will drop a new location soon. So this can be used for, say, publishing alarms that you get in from a distress signal, or marking locations, so such as a shipwreck or a person. So that information can be relayed to the crew members. Okay, so a quick glance at our API. We have endpoints for the drone to connect to, as well as a pilot and a spectator endpoint. So here the drone publishes its telemetry and receives controlled commands. The pilot can both receive telemetry from the drone as well as send commands to the drone. The spectator, we don't allow to control the drone, but we instead give it both the drone telemetry and video, as well as the, or not video in this endpoint, but we give the spectator the drone's telemetry as well as the pilot's command, so they can see the pilot is doing. We also have launcher endpoints to control the launcher, as well as a Janus media server, which is a great piece of open source software to relay video streams. So essentially, you can send one video stream up to the server, and then it can duplicate that video stream to how many users we want. So this media server is built on WebRTC, and that's what we use to publish the video from the drone, as well as subscribe it, because it has really good, well, both latency and browser support. We also have endpoints for the locations feature mentioned before, as well as some other services. So if we need to report our position to any application or service, we also have ADS-B in, as well as the Swedish integrations with the Swedish NOTAM system. We also publish and subscribe to AIS. So in AIS, like the transponder system at sea, there's a type of vehicle called SAR aircraft to see SAR search and rescue helicopters, etc. So we're registered as one of those. So the crew members on board can see us in their existing systems as a SAR aircraft. Having a quick look at our onboard architecture, we have here an overview. So we have the flight controller to the left, and the camera, as well as the camera, our Raspberry Compute module in the middle, and our 4G modem to the right. So we take the telemetry stream from the flight controller through Mavlink router, which we then split into our software that uses WebSockets to send it up to the API, as well as receive control commands. And then we also send it over a VPN. So in case of any sort of crash or something, we can always connect Q ground control over a VPN. We use PyMavlink in our own script to just take out the telemetry stream and send back control commands. And then we have this TCP stream. On the video end, we use GStreamer to get the feed from the camera. Here we support a few different cameras. So for example, with the Raspberry Pi camera, we use libcamera to get the video stream. We also support RTSP streams that come from several gimbals. We then package this in WebRTC and send that up to the media server so that it can relate to the users. Another thing that we spend a lot of time on is fail-safes. So this is an attempt to illustrate. So here in the top, in all the yellow boxes, you can, or all the sort of systems, everything from the user to the actual actuators on the airplane, and everything that can go wrong in between them. So for example, here to the very left, we have the user, and it can be distracted, gone, have gone to the toilet or passed out or something. And we, all the way to the, to if the, in the middle here, if the server crashes or if the cell network goes down. And so these are things that we have to take into account when designing the system so that we follow, well, both to assure air safety or air risk, ground risk, and as well to adhere to the regulations that we have flying in our D area in Gothenburg. So for our company, we're here now in late 2024. This past summer, we did about 9 BVLOS flights, covering a bit more than 500 kilometers in about 12 hours of flight time. This was an attempt to show our area of operations. We have a D area outside Gothenburg, which allows us to fly BVLOS. Next up, we have a new project funded also by innovation funding from the Swedish state, which is aimed at researching mobile coverage for drones. So, for example, a big issue we have seen is that the problem is usually not that we have too little access to base stations, but rather too many, so we get interference. That sort of, we notice it a lot in the video stream that we lose frames, etc. So that is a project that we're gonna continue with for a couple of years. Next November, the current iteration of the project with the Swedish Sea Rescue ends. Possibly with an extension or a new iteration, which we hope for. And the mobile coverage project will be active until late 2027. So some of the things that we aim to work with are improved fail-safe behaviors. We've also started looking into vertical starts to simplify the launcher has ended up being quite complex. So if we can simplify the starting procedure, we can really remove a lot of hassle there. We're also looking into, instead of landing in the water, we could instead land on the boats. So, for example, align the boat and the drone's courses and use some sort of object tracking to land on the boat. It's not terribly, since the drone is very light, these things are possible without creating or without damaging the vessels. We're also looking to extend into other domains. We have applied for several projects with wildfire protection and also just in general accidents on land. One good thing about flying over water is that ground risk is very low. It's very difficult to hit people or boats, which has, combined with our very low weight, gives us a lot of room while testing, and also helped a lot in the application process for our flight permits. We're also looking for new partners, and we would love with people facing the same problems as the Swedish Sea Rescue to try out our system. So if you're interested, I'll leave my contacts in the end, or you can just come up to me and talk. Making this presentation, it was a great opportunity to sort of look back on the last year on the learning outcomes that we've had. So one big thing is when you have so many instances of computation, or what do you say, like program modules everywhere, from the autopilot, Lua scripts, onboard computer, backend, frontend. You really have to be mindful where you place your program logic. And we've sort of found that it matters a lot when you create when you try to build autonomy on top of what already exists, pushing the software to the ends of those of this whole array of softwares makes it much easier to grasp mentally, which is one of the big challenges when we're trying new features, is that to see how all these systems interact, and the complex behaviors that arise. Another thing is one could imagine that, I mean, we fly a lot in the simulator instead of, but actually going out and testing it in real flights gives us so much good feedback, and it sort of tunes. It's almost like an emotional tuning that happens when you start flying, because it's, I mean, more intense, as you're probably aware, and then that sort of gives greater learnings. Another thing is also for this, or in the project, that you surround yourself with understanding teammates, and that mistakes will happen, and you just try to get as much learning out from those mistakes and crashes that you possibly can. So I wanted to take the opportunity also to thank the AudioPilot developers and contributors in general. This project with the Sea Rescue has generated a lot of attention in Sweden, and so many people have engaged themselves and put themselves in their free time, and I think more than 250 students have finished degree and industry projects within the Sea Rescue project. So and there's a lot of, we're 15 people working with the project as a whole, with everything from regulations to hardware and the launcher and software, obviously. So it really, we have a lot of contacts with Swedish universities, etc. So it has generated a lot of interest and sort of grit to solve these many issues that arise in this type of system. And yes, that's all I had. So thank you very much, and I gladly accept questions.
You mentioned the reduced ground risk. Given the use case, has your customer sort of imposed any requirements on your vehicle that has increased the requirement for reliability and mean time between failure, because it's important to rely on your system in part of that sort of life-saving mission?
Well, the customer is the Sea Rescue is very involved. So in the design of the plane. So Fredrik Falkman, who is my colleague, also works at the Swedish Sea Rescue. So he's been very strict about the weight requirements, just for the particular reasons of getting the permit and or getting our flight permit, and also reducing ground and air risk. So making the plane not dangerous has been sort of a ground pillar for the whole project. To have small, light aircraft that can do these things, and which also makes it less expensive and other things. So at least in the construction phase, but the design phase becomes obviously much more difficult when you're limited to that. So thank you. Any other?
So on the same vein, are you the operator for this aircraft?
Yes, so Fredrik, my colleague, and me are usually the ones launching and piloting. So here you can see how when we're out testing, we have this mobile launcher that a gas spring basically, and so we pull it away like this, and then we run into the offices. Get that picture.
And does Sweden fall under the EASA's SORA regulation as well?
Oh, sorry, and this is we run up to the office and start the interface. Sorry, what was the other question?
Does Sweden fall under the EASA's SORA regulation as well?
Yes, we have ongoing applications for a SORA permit, and that would be more generous. Right now, we're quite limited, we're geo-limited in space.
So my actual question is whether, what sort of percentage remote aero sacrifices to follow and apply and make application folders and do all this kind of regulatory process? Thanks.
I mean, the regulation, like right now, Remote Aero doesn't own the Swedish, like the sea rescue permit. But Frederick, that is also something he's looking into to do both in his role as at the Swedish Sea Rescue as well as at Remote Aero. So yeah, he has ongoing SORA applications now for the sea rescue, and but he also looks to extend that to maybe do things on land which aren't necessarily applicable to the sea rescue case, but would be to other applications and domains. Thank you. Any other questions? Otherwise, okay, one more. Sorry.
Sorry. Well, could you tell me about your flight termination hardware?
Yeah, so it's essentially like a small box that has its own battery, and it's connected over 2G, so we can send an SMS to it that basically cuts the power to the ESC.
Very cool.
So that it's actually like it's a thing for how do you say that, gym teachers with it's like a tracking device for kids when they're out doing orientation in the woods. But we work with that company, and they modified it to sort of be able to, and it also sends out GPS positions, so we can sort of get like every 30 or 30 seconds, we get updates on where the plane is, regardless of if the autopilot lives. And this box is also watertight and stuff, so we can, it's also there to help us find the plane if we lose it.
Very cool. And then my other question was that launch system you showed off, does it have a name? And is it robotic in the way where you're steering it into the wind automatically, or you're just controlling it in some way?
Yeah, so it's made by our partner company. Infotiv is like an embedded system and electronics company in Gothenburg. They work a lot with Volvo, but it's not a complete like finished product that they're selling. So I don't know if it has a name actually. But yeah, it's sorry, what was your other? Yeah, if it turns automatically, I think they have like wind sensors and stuff on it. So I think they can, but now we've just turned it manually.
Cool. Thank you very much.
Thank you.
Please. Nice UI there with the very good, very good. I was interested. The point of interest part. Are you using the internal commands from Autopilot? And how?
Yes.
If so, how have been the experience with?
So we try to use as much of our Autopilot as we can. So we have Mavlink end to end. So we take it out from the flight controller, and then we send it over to the web server as JSON, simply, and that is what we receive in the front end as well. So when I'm developing features in our front end, it's just sending pure Mavlink messages to our backend, which then forwards them to the plane. So yeah, I think that experience has sort of been pretty great. Been able to do, like, as soon as all the sort of infrastructure parts, as the forwarding was implemented, and we have a front end and all the deployments and stuff like that, doing the actual flight logic was quite, I mean, it's very easy to set up. We have a Dockerized like CIDL instance that we use, and yeah, that part was pretty straightforward to do. And so we use Mapbox for as our map library. So yeah, and that's also been nice.
Thanks.
Thank you. Any other questions? Thank you very much.